Hey all, Shiva Prasad here. I hope you are all doing great. This is another problem from our series, valid parenthesis. So, given a string contains just characters, these six, determine if it's valid or not. So, what are the conditions to determine it's valid or not? So, open bracket must be closed by the same type of brackets, and open bracket must be closed in the correct order, and every closed bracket has a corresponding open bracket of the same type. So here, if there is a open bracket, open parenthesis, then there should be close parenthesis. And here open close, and open close. So here we have open and close. So this is not a valid because there is no closing for this and there is no opening bracket for this. So that's all the problem statement. So let's see how we can solve this problem. I'm taking one positive scenario example here first. Right, this is true. I mean to say it's valid, right? We need to return true here. Let's see how we can solve. So when we get this kind of questions, the straightforward lookup data structure is stack. Okay, so how we can solve this? So we are going to have a stack data structure. Let's assume initially this is the stack. So if we are getting, if our character is of either this, either this, either this, I'm talking about first character, then absolutely this is not a valid string. Okay, we need to return false. So very first condition is what we check is stack is empty? Yes. Is given character equal to either this or this or this? Yes. Then return false because there is no opening for this right in our stack. Okay, this is our very first base condition. So what if this is not the case? Let's say here we got, okay, this is the one which we got. Okay, what we say? We happily insert this into here. Okay, it got inserted. You don't need to check anything when it is a open bracket, but you need to check something when it is a closing bracket. So if this is the closed one, then your peak element in the stack should be the corresponding open one. I mean to say, if given character is of either this or this or this, okay, then the peak element of the stack should be either this, either this, either this. Okay, this is the condition to determine whether it's a valid or not. So in this case, when we come to this position, we can see the opening this one. That's great. Then we remove this one. Okay, and we don't insert this because like we know this is a valid one now. This substring. Okay. Then we come to here. As I said, when it is open, no need to check anything, just insert. And when it is closed, check whether peak element is of the same closing bracket, sorry, same opening bracket. Yes. Then remove this. Then we come to here. It's open, then close. Sorry, insert. Then you come to here. Is the peak element of the stack is the opening of same type? Yes. Then pop this. So at the end, you need to ensure your stack should be empty. When your stack can be empty, logically if you talk, if the string is of valid, okay, then only your stack is going to be empty. In other words, how I can define is if string length is of even, okay, then only stack is empty. Am I right? Because for every opening bracket, there is going to be corresponding close bracket. That means the length of the string is going to be the even. So can we now, what I can say, check this even as our very base condition to determine if it is a valid or not. If it is valid, then it makes sense us to go and check whether this is really a valid or not, right? So even 110 percentage doesn't give you it's a valid, but if it is not even 110 percentage, we can tell it is not a valid, right? So even has two cases here, either valid or not valid, but or has only one possibility that is not valid. So in that case, I think we can happily check whether if it is even or not. If it is odd, then we can return false there only. If it is even, then only we can go and check whether it's a valid or not valid. Right? So that is what I'm going to do as part of our solution. So that's all for this. So maybe I can quickly take one more example which is a bit complex to explain and try run this approach. Let's say this one. Mm, okay, this is perfect valid input. Okay, I am going to take stack. What I said is stack empty? Yes. Is first character, okay, whatever you are receiving is of any closing bracket? No. Is it opening? Yes. Then you can happily insert here. Then you come here. Is it opening? Yes. You can happily insert here. Then you come to here. Is it opening? Yes. You can happily insert here. Then you come here. Is it open? Yes. You can happily insert here. Then you come here. Is it opening? No, closing. So when this is closing, what should be the peak element of stack? The corresponding open. Is it same? Yes. Then pop out this. Then go to here. Is it opening? No. Is it closing? Yes. What should be the corresponding peak element? It should be opening of the same type. Is it same? Yes. Then come here. Is it same? Yes. Then come here. Is it same? Yes. Then stack is empty. Then you need to return true. Return true. Let me quickly explain one more negative input set also. This is opening, closing, and then closing, then opening. This is not the what I can say valid, right? Because your parenthesis, so your this floor bracket should be closed after your square bracket. So now let's dry run the same by taking the stack and this. So this is stack. So is it opening? Yes. First we check is stack empty? Yes. Is it closing? No. Is it opening? Yes. Then insert. Then you come here. Is it opening? Yes. Insert happily. Then you come here. Is it closing? Yes. But what is the peak element of the stack? It's not of the same type. Right? Then you return here only the false. You no need to go further. When you don't get the peak element, when you observe peak element is not the same type of the opening bracket of the given corresponding close bracket, close, I mean to say operator, then you can return false there only. So that's all for this. I think you understood. So what is the time complexity? It's big of n, right? Because you are going to iterate through this complete stack elements, sorry, this complete string of each character. And space complexity also going to be big of n. In worst case, stack is going to hold all the characters. So that's all for this video. I mean to say this explanation. Let's quickly go and take my last submission code in order to save some time. So here it is the case. So if it is of opening, then you can happily push. Otherwise, then it is of closing. Okay. If it is of closing, if stack is empty, then return false. If it is of closing but stack is not empty, in that case the peak should be of the same type of what is the closing, it should be the opening. But if it is not the same type, then return false. If it is not same type, return false, return false. At the end, if these three conditions are not setting, that means the input is of either of this close and the peak element also either of these three. Okay, the same corresponding, I mean to say. In that case, you can remove that one, and at the end of this, your stack should be empty. If it is empty, that means it's a valid. So one more thing, as I said, you can write here also. You can return uh, int maybe some len, or else I don't know, maybe some result you take s mod, or else maybe you can take a boolean result s dot length length of 2. Okay, if if length is not equal to 0, okay, return false. Maybe you can, what I can say, optimize it and just write it. uh, what is this? int cannot be converted to this. Okay, cool. This should be the int, right? Because this returns you either 0 or 1. So it's fine. Then let me submit it. Yeah, it got submitted successfully, right? So now what you can do is you can even remove this one. You don't need to have this one, right? So still it works. Yeah, it got submitted. So that's all for this video, and don't forget to mark our tracker as a done. So this is third video on this series, so I'm marking it as a done. So on a high level we can see here we solved 3 out of 75, still 72 more to go. So thanks all for this video. I hope you learned something new today. Bye.